Button accepted.
So again, hello. It's nice to see you all. This is my third presentation, but actually this is the first one held physically, and previous ones were online presentations. And I can already tell you that physical presentation triggers much bigger emotions than virtual ones. And so I'm sorry if my voice will tremble a little bit, or if I will sometimes block or something. Hopefully it will all smooth out quickly, but please keep your fingers crossed. Okay, so let's start. Today we're going to talk a lot about contexts and why they are so important for us, for developers. And so the first natural question here is, what does this word context actually mean? And we will find out based on 3 examples, and I'm gonna illustrate these examples with this picture. So what we can see here, in the center, we have this 3D object, and look, depending on the wall, it casts 3 different shadows. We might say that this object might be interpreted in 3 completely different ways. So okay, let's look at the first example then. This is a diagram of a company's year-to-year revenue, and the question is was it a good or a bad year? And the answer is actually, it depends. We need a bigger picture to assess that. And so let's compare this revenue to the company's costs, and if the costs, at the same time the costs declined, this is actually good news, the situation is good. But if the costs grown proportionally to the revenue, we can say, okay, the situation is at least stable. And however, if the costs outpaced the revenue, this is bad news. Like, the company actually loses money. So in order to interpret the original diagram, we needed bigger picture. We needed to put some context. We needed to put it in some context. So another example then, look at this sentence. I've been waiting for you for so long. And what does it mean? If these are the words said by Romeo to Juliet, they mean love. But if these are the words said by, I don't know, Lord Voldemort to Harry Potter, then mean hate. Right now, maybe some of you even felt fear. And if these are the words told by the boss to an employee who is late, we all know what they mean problems to that employee. So again, in order to understand the sentence in the middle, we needed to know the circumstances. We needed to know the context. And the very last example, it turns out that even a single word can mean different things in different contexts, like the word row. So in an Excel spreadsheet, row is a horizontal line, horizontal list of cells. In a theater, it is list of seats. And in a boating sport discipline, to row means to move the oars to accelerate your boat. And with these 3 examples, we learned that context can mean surroundings, it can mean circumstances, and also it can mean bigger picture. And we learned that if we have an event, a sentence, or even a word, we need to first add a context to truly understand the meaning of that thing, to truly understand what we are looking at. So right now, your reaction can be like this one, meaning, okay, Łukasz, nice philosophical intro, but what all of this means to us, to developers. So I will explain this in a minute, but let me first finally introduce myself. So who am I? So again, I'm Łukasz Panek, and I'm a backend developer for 11 years now. I work for Big Picture for 5 years as senior backend developer and team leader. And professionally, I'm a big fan of domain-driven design, clean levels of abstraction. Actually, some time ago, I made an experiment on what can happen when you mess with that levels. If you're interested, here is the link. And also, I'm a big fan of dependency inversion principle and inversion of control techniques. And here is my last year's presentation on that, if you're interested. And privately, I'm a big fan of space exploration, you know, NASA, SpaceX, Tesla, with electric vehicles and all. And attitude called growth mindset. I believe that this attitude is especially useful for us developers. So if you're interested, here you can find more data on this. So regarding context and regarding contextual models, I'm interested in these topics for half of my career right now. And this presentation is kind of like the essence of what I learned throughout that time. So since many things that I learned while working at Big Picture, I thought that maybe if at the end of the presentation, like some of you will think, okay, this was a nice presentation, I liked it, maybe you will be willing to give Big Picture a try. So if so, I have this quick slide for you about the company. And here are two links. The first one is the video in which me and my colleagues explain why Big Picture attracts us. And the other one is the careers page. And here is the screenshot from our current Java developer offering. And please keep in mind that we accept 100% remote work as well. Okay, enough with company placement. Let's go back to the main question, which is what context mean to developers? And I prepared some real-world examples to show you that. And the first example, the main example, is from the buses domain, specifically from servicing buses in a public transport company. And in this example, we will follow two different teams who will produce two different designs. Like, we can imagine that this is like the alternate reality. What would happen if we pass that system to the one team, and what would happen if we pass that to the other? Okay, so let us meet the teams first. The first one is Team Unifiers, and the second one is Team Contexters. And actually, these teams are quite identical, practically identical. They have the same size, they have the same roles, like backend, frontend QA, product owner, Scrum Master. They have the same seniority, both work in Scrum. They both know clean code rules, so they know, for example, that their functions should be small. They know solid principles. They know that cohesion should be tight and coupling should be loose. They know DDD value objects. So, for example, they know that ID of a bus should be represented as a dedicated object, as a bus ID, not as a primitive like long. They also know DDD aggregates. So they know that, for example, their model should not be anemic with getters and setters, and they know that aggregates are for enforcing business rules, and that, for example, they should be versioned in order to avoid inconsistency problems. Also, some other DDD building blocks like services, like repositories, factories, or events. And finally, they have the same knowledge regarding frameworks like Spring, Hibernate, Angular, etc. So what's the difference between the two teams? The difference is that the first one don't understand the importance of contexts, and the second one do. And now we will see how that apparently small difference can make a huge difference at the end, at the final version of the system. Okay, so let's look at the initial system requirements. So we have a government of a full city, and that government wants to promote public transport in the city. And the government has bought some new buses. Actually, its number doubled from 50 to 100. And the problem is that the public transport company has only 4 mechanics. And they can't cope with servicing of such number of buses. And by servicing, I mean replacing oil engine, checking air conditioning, replacing used tires, all that stuff that is done on a regular basis. And after first analysis, it turned out the problem is not that there is too much servicing for the mechanics. The problem is that there is too much calculation of next servicing windows for each bus. Just imagine, a bus rides 7 days a week. It makes a huge amount of kilometers. And that means that on average, every week, 1 bus should be serviced. So for 100 buses, this means 15 buses a day. And now you are the one who needs to calculate, to foresee when that moment in time happens, when the bus, for example, gains this mileage to be serviced to replace the oil. And you need to do it on a regular basis for 100 buses. I believe that you can feel that pain already. And it turned out that tracking these windows started to be one of the mechanics' full-time job. He actually doesn't have time to do anything else. And unfortunately, he made some mistakes, which resulted in 2 buses broken and in 1 insurer rejection. So that means that company already lost some money. And mechanics are now afraid of next mistakes, and they are tired of working overtime. So the company wants to help them. It wants a small IT system that will calculate these windows automatically for mechanics. And so here is where our teams enter the stage. And let's look at the solution proposed by the first team, by Unifiers. They quickly identified that the main thing in this world are buses, their parts, service windows, and service actions done during these windows. And that the main rule here is that two service windows cannot overlap with each other because that would make no sense. So the team created bus aggregate to enforce that rule and to express all the necessary operations. And they are like add part, edit part, remove part. And a part is a simple data. It has its ID, its name, but what's more, it has rules, a set of rules, service rules. And an example service rule is engine oil replacement rule, which tells us that after given mileage, like 10,000 kilometers, or after given period, like 1 year, whatever comes first, you need to replace the oil, and acceptable oils for given engine type are like this. Okay, so these are the methods for the part management. And we have methods for managing service windows. So the main method, propose service windows, this is the method that the company was most interested in. So the system proposes service window, mechanic can accept them, and when the time comes, mechanic starts the window. During that window, mechanic does all the service actions planned within that window, and when he's done, he finishes the window. So service window is again a simple object with its start and end dates, with status like proposal, accepted, in progress. The methods that we just saw move that object within, through that statuses. And service actions collection, and actually service action has a reference to a given rule and some details like what was the oil chosen or something like that. Okay, and this is the method, the accept service window proposal. This is the method that protects this business rule of windows not overlapping, because this is the moment when a proposal transforms into real fully fledged window. And we have also some other simple methods like set total mileage, set forecasted daily mileage. System needs to know that to forecast when the service window should be planned. And the fields, ID, parts, service windows, total mileage, forecasted, plate number for representation purposes, and the version. Okay, and apart from the bus aggregate, the team created an application service called bus service. This service works based on the aggregate. It has very similar methods to the aggregate itself: add part, edit, remove, propose, accept, start, finish, etc. And let's have a look at the propose service windows method. Actually, it's super simple. First of all, it loads the bus by ID, then it calls its command, it changes its internal state, and then it just persists the changes and increments the version along the way. And regarding the propose service windows method, what's done inside? First, we calculate upcoming actions based on the forecasted distance traveled each day. Then nearby actions are grouped into window proposals, and then we update the internal state, the service windows field. Okay. So now let's move on to the contextors. Actually, their proposal was exactly the same as unifiers, but when they proposed that, they started to discuss it. And one of the members noticed that, okay, parts are changed less often than service window. So this was an example of rate of change analysis. The other guy noted that, okay, parts management maybe is a different business process than service windows management. So this was business processes analysis example. The other one noted, most methods work on most data, so the cohesion is tight. However, there is this field plate number that is actually used only in a setter and getter. So this was cohesion analysis. However, all members soon agreed that all the classes aren't that big, and what's most important, this is just the very beginning of the project, and actually we don't know whether a customer will want to develop it further. We don't know whether the new requirements will be, what new requirements will be. So the team decided, okay, current design is good enough, we'll take it. And so after a month or so, both teams were ready, the system was deployed, and it was a great success. Actually, this is a gift that the team of mechanics sent to our teams. And since the first version was so successful, soon the customer requested more. And the new requirements were like, mechanics now want to know when each bus rides the bus line, because they don't want to plan their service window during bus ride windows. Again, they don't want the two to overlap with each other. At the same time, the person responsible for assigning buses to lines and to drivers, called the planner, wanted to define similar write windows and their proposals, just like mechanics did. And the planner just wanted to know about service windows, again, to avoid the collision between he or she and the mechanics. And there were also some other bus parameters that the planner wanted to have in order to better do his or her job, like distance traveled per single refueling, or duration of single refueling, or is bus zero emission because government rules prohibited other buses from entering the old town. And again, how these requirements were tackled by the unifiers. First of all, they created new application service called Bus Ride Service, dedicated to the planner needs, and they added there all the necessary operations. They are quite similar to the ones for the mechanics. And regarding the bus service, the service created during first iteration, all they needed to do was just to change its name. And actually, funny thing happened along the way because they wanted to add service word in the middle, and this is a nice example of again, how can one word mean different things in different contexts, because the first word, service, means business domain of servicing or maintaining buses, and while the second service word is from a technical word, is a technical word of application services introduced by DDD. As awkward as it looked, the team accepted this name, and actually I can agree with their decision. Sometimes such things just happen. And okay, so what about the bus aggregate? And the bus aggregate, this is its shape from the first iteration. And the team, in its first proposal, they just simply added all the methods needed by the planner. And this decision sparked a new team discussion. So one folk stated the obvious: the class is much bigger now, mostly due to the right window support, but also due to new attributes. However, the other one noticed that, okay, right windows need to be here because there is this rule between them and between service windows. And the other one added, okay, the other reason for having all the things here is that we need to show them all on a screen for mechanics or for a planner. So the team felt like kind of stuck. They didn't know what to do. Like, they didn't like the size of the class. However, there was this rule that kept everything together. So finally, one of them just said, okay, maybe this is just our system that is different than others. Maybe we just need to forget the rules for a moment here. And soon all the other guys agreed with him, and they just concluded, okay, in the future we will see. New requirements will drive us. So this was their decision. Okay, so what about contexters? They landed actually with the same decision, with the same design. They created this huge class at the very beginning. And again, they also started to discuss about it. But this discussion went differently. And here's the transcript. So again, this class will be too big. It needs to be split. And the other folk noticed, okay, planner, look, planner is a completely different actor. Previously, this class served only mechanics. And right now, we have second planner actor. So this was business actors analysis. Another observation was super important. These actors use different languages regarding to buses. Mechanics talk about oil replacement, tire checks, while planner talks about assigning lines and drivers. So this was language analysis. Another observation, these actors take part in completely different business processes, servicing and planning. And actually it was unwise, according to that guy, that, for example, finishing service action by a mechanic and changing assigned driver by a planner can conflict with each other. Because remember, we have one aggregate with one version. So if two users do it simultaneously, we can have a conflict while saving the data into database. So this was business processes analysis. But again, someone raised this thing that there is this rule between the windows. They cannot overlap. We need to prevent this. We need to have this data together. And again, this team also was stuck, but they just didn't give up. They decided that they need to think harder. And what this team intuitively knew is that bus is a complex real-world thing. And as such, it shouldn't be modeled with one model only. They knew that with a planner requirements, we have now two contexts, bus service and bus ride. And in the bus service, we talk about things like service windows, oil replacement, parts, total mileage. While in bus riding, we have ride windows, lines and technical rides. We have assigning lines to drivers, etc. However, there was, one more thing. The team knew also this general rule that models in source code should not mirror real-world thing. They should not mirror the thing in the middle. Models should, in source code, should mirror mental models that business experts, and business experts are the users who know the domain. So models in source code should mirror mental models that business experts have about these things in their minds. And however, there was this connection between service and ride windows that just prevented them from splitting the aggregate into two. So they started brainstorming. And actually, they didn't need much time. It didn't take much time before one of the folks said this thing. Maybe we should just extract that common part of adding, editing, removing windows into some other place. Okay, and what will be the name for that part? It is related to bus availability management, something, like making reservations, bookings or something. And actually, that was it. That was all they needed. They needed bus reservation model. And it turned out that they actually uncovered the deeper model under the hood, a third context, bus reservations, just not yet realized even by the experts like mechanics and the planner. And this model, the model inside this context, was actually super simple. It consisted of these methods, and voila, that was the missing part. So what was the design finally proposed by contexters? First of all, the code created in first iteration, they moved it to a dedicated bus service module. We can think of it as a Maven module, for example. So they put their bus service, the bus aggregate as we know it. And also they created another module called bus ride module, crafted to the needs of planner with bus ride service and another aggregate. This is the second aggregate just with the same name and the methods for the planner. And they just connected both modules. They linked them to the third module, bus reservation module, with this bus reservation service having all the methods: add reservation, edit, remove, and get bus reservations. And okay, let's stop for a second here. If I were you, I believe right now I would be like this puppy. I mean, okay, this design looks interesting, but I have some questions and I don't yet know whether I like this design or not. So let me now try to guess what may bother your minds, and I will just try to answer several questions. So the first possible questions that you might have is, okay, how to use this bus reservation service, this third context. So let's look at the example. At the operation accept service window proposal. This is the moment when a proposal transforms into fully fledged window. So at that moment, we need to prevent overlapping the windows between themselves. So the first line is adding the reservation. We call the reservation service from the third context. We pass to it bus ID. We pass bus service module as owner ID because service module is the owner of this reservation, and we get in return reservation ID. Then we simply find the bus in bus repository and we call its command accept service window proposal. And here is the moment where we connect window ID with its reservation ID. This is the moment where we connect two different contexts, let's say. And if everything is fine, we just persist the changes. Okay, and two notes here. All above is done in one database transaction so that we guarantee that the consistency between the reservations and the bus aggregates. And okay, we right now modify two aggregates in one transaction, and some of you may know this rule of thumb: don't change more aggregates than one in a single transaction. And actually, we may ask, okay, so what for is this rule? This rule exists to prevent scalability problems, meaning regularly changing a lot of data at once. And what about reservations? Previously we said that bus reservations change once every week or so. So there is no risk of scalability problems because this is the data that is not created or changed very often. And please remember that rules of thumb exist to make us think twice, to make us stop and think our design. They are not dogmas, they are not always true. They are actually nomen omen, they are contextual as well. So this was the first question. Your other question might be, Okay, what about showing data on UI, which was actually Team Unifier's main concern? And this concern may arise because right now we have data spread into 3 different modules, into 3 different places. And what if we want to show data on one screen that comes from multiple places? So let's say that we create bus DTO for a mechanic screen, for example, that will be needed by the UI. And this DTO has ID, plate number, service windows with details, because this is screen for mechanics, and they want to know what are the actions inside the service windows, and they want to know right windows. However, they only need to know the start and end date because they are mechanics. They don't bother whether this is assigned to this or other line. So what the team did, what Contexters did. Contexters created actually another module called bus presentation module with this bus presentation service, and its duty was to create the bus DTOs and how it was fulfilled. So bus DTO ran 2 queries. First query, it asked reservation module for service windows and right windows for their dates, and the second query then for loading plate number and loading the details of each service window which were inside the service module. And this solution may trigger 2 new questions in your heads. And the first one is, okay, right now we have 2 queries to the database. This means performance drop. And my answer is this really a problem? Is this drop noticeable? Actually, if it indeed is, there are several solutions, like we can cache bus DTOs and clear that cache on any relevant event. So this is the solution to the possible problem. It may not arise in the first place. And your other question might be, okay, and what if data changes between first and the second query? Like, for example, what if in the meantime a window gets deleted? So this is actually a good point, and bus presentation service should be prepared for this. And for example, if it detects inconsistency between the queries, it can just rerun the queries, or it can just show a message to the user, dear user, please refresh the page because something changed while I was loading the screen. Okay, so this was the second question. And your third possible question might be, okay, what about bus ID in both aggregates? Because both aggregates have this first field called ID. Is there any connection between these IDs? And indeed there is. Real-world bus, each real-world bus should have exactly the same ID in both modules. And actually, you may ask why? Because like both modules store their reservations in one place. So in order to have everything consistent, they need to use the same ID for one real-world bus. And how to ensure this? The team decided that they will add create new bus method to this bus presentation service, from this new context from the very beginning. And in this method, they generate bus ID, then they pass it to bus service create new bus, and to the other write service, so to the other contexts. And all of this is done in a single database transaction in order to keep consistency along the modules, along the contexts. Okay, and the last possible question, maybe there are more. What about duplicated data, namely the plate number field? Because we saw that actually both aggregates have this plate number. This is duplication. What shall we do with that? And let me first of all notice that the plate number does not participate in any business rule. Actually, this field is stored in aggregates only for presentation purposes. And so the team had 2 options here. First one, to duplicate this field in both classes, and this is actually what they chose. And the second one was to create another dedicated bus model bus class and move that field there. However, the team felt that this would be an overkill, and that actually plate number changes very rarely. Like, just think of yourself, how many times in your life you changed plates regarding your vehicles. So the team again chose that they will add update plate number method to the bus presentation service. In this method, they will use both sub-services, and they will make the changes in one transaction to make sure that everything is consistent. Okay, so let's sum up what we already know about Contexter's multimodal design. Let's start with the disadvantages, with the cons. So, if we have many models, most probably we need to ensure common ID while creating related entities. We need to ensure consistency while updating duplicated data, provided that such data actually exists. And we need to ensure performance while presenting this data, and inconsistency tolerance if many queries exist. And what about the advantages? The first advantage is that we have several small contextual models that are tailored to the needs of a given context. And as such, as a result, these classes are smaller, have higher cohesion and single responsibilities, and are also easier to test. And the second advantage is that system is easier to change. It easier absorbs new requirements. And actually, right now, you might be like, are you sure, Łukasz? Like, please first prove it, that indeed this model better absorbs requirements. So first, let me add that this second iteration was also a big success for both teams. However, of course, contexters needed some more time, but they happily managed to keep the deadline. So what were the new requirements? What was the third iteration? And we will see whether indeed the second model absorbed the new requirements better. So the new requirements. New customer arrived, a government of Bar City. They also wanted that system. However, there was one thing. Bar City had buses and trams. At the same time, mechanics from Fu, they wanted the system to track not only service windows, but also bus breakdowns. And the third requirement, planner from Fu, wanted the system to recommend bus drivers to assign, based on historical rights and based on drivers' availability. So as you can see, things got hot. And what is more, in reaction to all above, your project manager decided that from now on, the system will be developed by one more team. And the manager wanted our team to decide what responsibilities to transfer to the new colleagues. So what was the response from team unifiers? Actually, they remembered how big their class bus already was, and some of them reacted this way, and the others even this way. And so let unifiers for a second, let them recover, and let us see what contexters did in the meantime. And contexters' reaction was like, let them come, let the requirements come, we will tackle them. And so what was their response? Contexters started with drawing their module map. Remember, we had these three main modules, service, right, and reservation module. And regarding the first requirement, the support for trams, the team decided that they will create two dedicated contexts for them, tram service module and tram right module. And they didn't want to put the tram-related code into the bus-related modules for two reasons. The first is that they learned from the mechanics that from a mechanic point of view, servicing a tram is completely different than servicing a bus. Like, you need different set of skills. So they are like disjoint things. And the second, even more important argument for splitting the code was that only city bar requested for trams. So the team didn't want to have tram code in a bus related modules, because that would mean that for a full city they would need to have bigger code to maintain. And the only question that remained was, okay, so what to do with tram reservations? Like, intuitive solution was to just link these new modules with bus reservation module. However, this was bus reservation module. It was tailored to the bus needs. But was it indeed? Like, the team thought twice, and they actually realized that from a reservation perspective, there's actually no difference between the buses and the trams. So what they did, they just renamed this module to vehicle reservation module, and that's it. That was all they needed to do. And let me just now move this module to the center of the screen so we can have a better understanding. Okay, and what about the second requirement, which was support for bus breakdowns? Again, the team identified that this is another context, and they created a dedicated module for it. And again, you may ask why. So they did business processes analysis, and they spot that in the context of breakdowns, there are some processes, business processes, that do not exist in the service context, like, sending broken bus to a bus producer as a part of agreement, or communicating with bus insurer. These are the processes that do not exist in servicing. So the only thing that remained here was bus parts, because the two modules were dependent on them. And again, team decided to move the parts to a separate part module, and they only left service rules in the service module. And actually, as you may remember, this was the idea that they had from the very beginning. They thought, even at the iteration number 1, that they might split parts from servicing in the code. But now they had just another argument, strong argument for that. Okay, so we have one last requirement to go: the recommending bus drivers to the planner, and that was actually just quite simple. The team just added driver recommendation service to the right module, and regarding the support for drivers' availabilities like sick leaves, vacations, etc. Again, they realized that the vehicle reservation module that they already have is very generic, so they just rename it to the resource reservation module, and with this single module, they now handle buses, trams, and drivers. And actually, this reservation module is a really nice example, I think, because until now, we saw examples where we split real-world objects into smaller contexts, while regarding this reservation context, we do the opposite, actually. Like, from this module perspective, different real-world things like buses, trams, or drivers are just the same. So I think it's good to know that that context may work in both directions. We can split real-world things, or we can merge them because there is no difference from that perspective. Okay, and the last thing to do was to pass some work to the new team. This is what project manager wanted. So how contexters did it? They knew that the other team is new to the domain, so they decided that they will pass them a easier part of work. So they gave them creating these new modules, which were actually at that point more or less copy-paste of the bus-related modules, and they gave them the work of generifying the resource reservation module, and they left for themselves the harder part. And that's it. Contexters are done. So let's now return to unifiers. And unifiers recovered, and they decided that, okay, we have no time to waste, we need to learn. So they started reading books, watching presentations, even participated in some courses. And they finally understand what they were missing: contexts. So they decided that, okay, right now we know Kung Fu, and we can change our code. So they wanted first to introduce contextuality into their system, and only then address the new requirements from the iteration number 3. And I need to be honest with you right now, guys, because in the presentation description, I declared that I will show you now how to refactor unified model into contextual one. However, while I was working on that part, it turned out that actually this is a big story, and I simply do not have time to show you that. But I have a proposal. Please note down this link if you want to, and I promise that by the end of next Wednesday, I will put there a second mini presentation, and I will show you the whole story. I just need some more time to, because there will be no me talking. I need to write down my comments in the presentation, so we will see. I hope that's okay for you, and sorry for the inconvenience. So actually, this is the end of this big bus example, and I have 3 more examples, but don't worry, they are super small. And in the first example, I want to show you that not only big, complex things as buses are contextual, also super simple things as chairs, for example, can be contextual as well. So right now, each one of you can look at the chair that you are sitting on, and I can ask you a question. What is important in these chairs from your perspective as a conference participant? I believe that as a conference participant, you are mostly interested in distance from the screen. You want to make sure that you can see the letters. And what's important from the conference organizer point of view? Chairs dimensions, because organizers just want to make sure that people have enough, that they can fit enough chairs to have all the people. Actually, we failed a little bit, as we can see, with that duty. Okay, and what about store worker, the guy who keeps the chairs in a store between the events? You may answer that, again, he's interested in dimensions, and you are right, but this is not the complete answer, because what matters to a store worker are the dimensions of a chair stack, because this is how a store worker keeps chairs in a store. So even such simple thing as chair can be contextual. Depending on who's looking at it, he or she can see completely different things. Okay, so let's move to the second mini example. And in the second one, I want to show you that not only physical things like buses or chairs can be contextual, also abstract things can have contexts. And by abstract things, I mean things that exist in the real world, however, we just cannot touch them. And examples are, love, justice, or a football club. So let's have a look at the football club then. And what do you think? What such club means to its owner? I believe that I will do a huge oversimplification here, but from my point of view, for an owner of a club, it is all about money. So the owner is interested in players' costs, in tournament prizes, in sponsors' input, etc. And what about club coach? So club coach, of course, he's interested in player skills, in trainings, in opponent strengths and weaknesses, and in tactics. Okay, so what about club fans? What club means to them? And actually, for a real club fans, a club is simply everything. Like, it is more than life. Yeah, so this was the second example. And the third one is about presentations, like this presentation, because presentation is also an abstract thing, but in this example, I just want to show you that we can split real-world things into context, not only based on the users, but because these things evolve over time. So just let's have a look. And actually, what do you think? How my presentation looked like a month ago? A month ago, there was we were in a call for papers phase. So actually, my job then was to submit a proposal. And in reaction, organizers assessed that proposal. If they needed more data to make their decision, they could ask me for sending some sample slides or sending more detailed abstract. But if everything was fine, finally they accepted the presentation. So this is what happily happened. And from now on, everything changed substantially because we went to the presentation preparation phase. And right then my duty was to indeed prepare the presentation, while you could click the like button to just give me and organizers a hint whether this is a nice topic or not. And organizers, among many other things, they needed to schedule a day and time of my presentation, and all others as well. And then the time has come, and right now we are here, we are now, and this is the presenting phase. And my role here is to click slides and keep talking. Your is to follow and to ask questions at the end. And again, within some minutes, the time will be up, and we will move to another phase. So look at these three events here, the highlighted ones. They are events that changed everything, and we call these events pivotal events. So these are the events that change given thing substantially. Like this thing becomes something completely different from that point on. Like this moment transforms that thing into something new. In other words, like these events change the rules of the game. Like many current operations are no longer valid, they are replaced with new ones, and we can see it on the screen. Like in each phase, the operations changed a lot. And so these events changed the presentation so much that in fact we can say that in each phase we dealt with completely different objects. So in the first phase there was a presentation proposal, then there was upcoming presentation, and now we are doing ongoing presentation. And actually the same happened with the service windows. The team should have modeled the window proposal as a different object than the windows itself, but I just didn't want to overcomplicate the previous example. Yeah, so right now you may ask, okay, how to spot pivotal events in our models? And the answer is actually quite simple. So just look at your class, and if you see that this class has many statuses, sometimes with sub-statuses even, and if you see that the methods in this class rely heavily on these statuses, meaning like at the very beginning of a method you have this check that if a status is different than you expect, throw illegal state exception or something. So if these are the case, if these two are the case, so this must probably mean that, okay, some statuses are indeed results of pivotal events in your object's lifecycle. And the solution is simple, just split your class based on these statuses. Not all of them, only the pivotal moments. And to show you that having multiple presentation models is better than having big one presentation model, let's imagine a new requirements arrive. And they are as follows. Main sponsors are given presentation slot automatically, which means that call for papers is not needed for them. In short, sponsors go through shorter path. So how can we tackle this requirement when we have multiple models? And actually, the answer is that simple. We just create upcoming presentation. We start from that second context. We just omit the presentation proposal. And that's it. We're done. However, if we had this unified big model with one big presentation class, we could run into problems like we might need to bypass some rules that are specific only to proposals that exist in this class, or we would have to have this annoying duty to somehow fill non-null database columns specific to these proposals. Okay, so this is the end. This is the end of the last example. I'm afraid that your heads might be buzzing now. So just let me sum everything up, and we are done. So, so the summary. And actually, if there is one thing that you will end up remembering from this presentation, please let it be this slide. So, for any real-world thing, either physical or abstract, it may look differently in the minds of our experts. Like, depending on the context, business experts can have completely different understanding of what given thing is. Like, like for one, it can be rectangle. For the other, it can be triangle. And for the other one, also, it can be a circle. So as a result, our source code models should not mirror real-world things. Our models, they are there to help the users, the experts, so they need to mirror mental models that these experts have. They need to be as close to the mental models in this context as possible. And this results in multiple contextual models in the code, and this is the opposite to the big unified model approach, boom, in short. Okay, so again, what are the advantages of contextual models? So they are small and they are precise, so each one is tailored to the needs of specific context. They are composable and extendable, so they can be rearranged to the new requirements, and with only little work, so you can think of the models as a building blocks that you can play with. And they are removable, so it is easy to replace them with a new model. For example, when the team discovers a better solution or in case of this, for example, reservation generic module, we can replace this module with a library or something. And they are microserviceable. So if a model is well crafted, we can easily move it to a separate microservice. And the cons, the disadvantages, we already know them. Presenting data may be more cumbersome due to performance and consistency concerns. But first, we have to assume that such data indeed needs to come from different models. Updating duplicated data has to be done in a consistent way, again, assuming that duplicated data indeed exists. And last but not least, contextual models are an investment. And this investment will return only when new requirements arrive. So this is the reason why in the first iteration, contexters accepted the very first design. They just didn't want to invest because they didn't know what a customer will do next. Okay, and finally, a toolbox for all of us. What are the techniques for identifying contexts? I already presented them, but let's have them on one slide. So first of all, listen to the language of your users. Spot the differences in the sentences they build, because since we cannot, as developers, read their minds directly, like this is the only way for us to identify that, okay, this guy or this guy has something different in his mind that we can think. The others, if you're interested, ubiquitous language and bounded context from DDD may help. The other technique, visualize business processes, and event storming is a nice solution for this visualization. Also, identifying business actors and analyzing the rate of change of particular business models can help a lot. Search for pivotal events. Remember the hint. Just look for statuses and substatuses. And there is this nice perspective, being, behaving, becoming. It's really worth learning about it. And analyze cohesion. And finally, you may just ask your model, dear model, what business questions do you answer? And if there are too many of them, just split the model. And actually, you might now ask, okay, this is quite a huge list, what shall we pick? And the answer is simple. The more techniques you will use, the better for a given situation. You will just get a bigger picture of everything, and it will help you make a more wiser decision, whether you want to specify a new context or this is not the time yet. Okay, and if you want to learn even more, I can recommend you Better Software Design podcast by Mariusz Gil, and actually Mariusz Gil and Kuba Pilimon, I believe we all know these two, do a great job in regards to contextuality awareness among developers. Or there is one more solution, you can just simply join Big Picture and we can work together on the modules and context that we have in our system. Okay, that's it. Thank you very much. If you have questions, thank you. If you have questions, I don't know if we have time. It's ideally 20 after 11. So if you have questions, we can talk. However, I will be in a Big Pictures booth for the rest of the day, so we can also join me and we can talk. Me or my colleagues, we will be more than happy to answer your questions. Thanks.